In our lesson today, we're going to be learning about compound independent events. And before we take a look at our first example, we should understand what these words mean, all right? When we're talking about compound events, all right, the word compound is going to be more than one. More than one. Okay, like a compound word in English class is a word that's made up of two words, like driveway or basketball, something like that. A compound event is going to be made up of more than one event, so it's going to be two or more. And when we say that they're independent events, independent means that the second probability is not influenced by the first probability. Okay, so compound means more than one, and independent means that the second probability is not going to be influenced by the first probability. And so let's take a look at an example. It says to make a tree diagram for the two-stage event of rolling a die and spinning the spinner. Okay, so we see our die labeled 1 through 6, and we have our spinner labeled with sections E and S. And we're going to start by making a tree diagram for this. Okay, so the first thing that we're going to do is roll the die. Since the die has 6 sides, I'm going to start my tree with 6 branches. So let's go ahead and draw 6 branches. 1, 2, 3, 4, 5, 6 branches, and we're going to label them with the numbers 1 through 6. 1, 2, 3, 4, 5, 6. Okay? After we roll the die, we're going to spin this spinner. Okay? Now, this is an example of an independent event because whatever number we get on the die, that does not influence what we can get when we spin the spinner. Okay? So if I get any of these numbers on the die, I can still get either E or S on my spinner. And so off of each one of these numbers, I'm going to have 2 branches. So let's make 2 branches off of each of the numbers. Okay. And then once you've drawn your 2 branches, we're going to label them with E and S. Those are the 2 possibilities when you spin the spinner. So let's go ahead and label each of these E and S. Okay, and now we're going to create our list of all outcomes, the sample space. So just follow your branches. The first outcome is going to be 1 and then E, and then we're going to have 1 and then S, 2 followed by E, 2 followed by S, 3 with E, 3 with S, 4 with E, 4 with S, 5 with E, 5 with S, 6 with E, and the last is 6 with S. And again, count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 12 outcomes for this compound event. Okay, so when you spin the spinner and when you roll, when you roll the die and then when you spin the spinner, that's going to give you 12 possible outcomes. Based off of this list, we're going to answer these probability questions. So our first probability is getting an even number followed by E on the spinner. Even number on the die, 2, 4, and 6, okay, followed by E. So that's going to be 2E, 4E, 6E. So that's 3 out of the 12, which would simplify down to 1/4. Okay, next probability, we want a number that's greater than 2, followed by either E or S. It doesn't really matter what you get on the spinner. Okay, so as long as the number's bigger than 2, so that's going to be your 3, 4, 5, and 6. So it's 3E, 3S, 4E, 4S, 5E, 5S, 6E, 6S. That's going to be 8 out of the 12. 8 out of the 12, which would simplify down to 2/3. Okay, both of those numbers are divisible by 4. The last probability, we want a factor of 6 followed by the letter S. The factors of 6, well, the ways that you can make 6, you can do 1 times 6, or you can do 2 times 3. So 1, 6, 2, and 3 are the factors of 6, and it has to be followed by the letter S. So that's going to be 1S, that's going to be 2S, 3S, and 6S, 4 out of the 12, which will simplify down to 1/3. So we just created a tree and a list to answer the probability questions, and we're going to ask, is there an easier way to find probabilities without having to make tree diagrams every single time? And the answer to that, of course, is yes, we can do this a different way. Okay, what we're going to do, we're going to take a look at each of the questions that we did before, questions 1, 2, and 3, and rather than looking at the tree and the list, we're going to think about these as individual probabilities or simple probabilities and find those first. So if I want to get the probability of getting an even number on the die followed by E on the spinner, I'm going to first find the probability of just getting an even number on the die. Well, again, the even numbers are 2, 4, and 6, so there are 3 even numbers out of 6 on the die. Okay, and then for the spinner, the probability of it landing on E, well, there was only one E out of the 2 sections. Okay, and then again, when we did our tree diagram and made our list, we knew that there were 12 possible outcomes, so our probability was out of 12. And looking at my fractions here, well, I can see that 6 times 2 is equal to 12. So to get my numerator, all I'm going to do is multiply 3 times 1, 3 divided by 12, or 3/12 I should say. And then if I simplify that, that's going to give me a probability of 1/4. Okay, and looking back above at example number 1 right up here, there it is. Okay, we had the probability of an even followed by an E. We looked at our list and found that it was 3/12 or 1/4. Now we've shown it a different way. Okay, so we can find each simple probability and then we can multiply those to come up with our final compound probability. So let's try that with the other 2 examples. The next one that we're going to do here, we want to get a number that's bigger than 2 followed by E or S on the spinner. So start first with the number bigger than 2 on the die. That's the numbers 3, 4, 5, and 6. So 4 out of the 6 sides are bigger than a 2. On the spinner, to land on E or S, well, that's both of the sides. That's 2 out of 2. You're going to land on E or S. And now when we multiply 4 6 times 2 halves, that's going to give me 8/12, which will simplify down to 2/3. And again, that agrees with what we did up in example 2 above. Number 3, the factors of 6 on the die followed by S on the spinner, starting with the factors of 6. Well, again, we said that was 1 times 6 or 2 times 3. So there are 4 out of the 6 that are factors of 6 on the die. Getting S on the spinner, that's a probability of 1/2. And if I multiply 4 6 by 1/2, again, I'm going to get 4/12, which I can simplify down to 1/3. Okay, so instead of making a tree diagram and a list every single time, if I just want to get the probabilities, all I'm going to do, here's our rule. We're going to multiply each simple probability. Multiply each simple probability to find, I should say, I'm getting ahead of myself. All right, to find the compound probability. Okay, the rule, multiply each simple probability to find the compound probability. Again, simple probability is the probability of just one event. That's why we broke these up into single events, and then you just multiply them to get your total compound probability. In the next examples, we're going to be using a 6-sided die. We're going to be using this spinner, which has been labeled green, red, and yellow. And we have cards that spell the word wallet. Okay, and we're going to find probabilities using these items. And again, this is an example of compound probability because we're going to be doing more than one thing. And it's independent probability because the numbers on the die don't affect the colors that are on the spinner. The numbers on the die don't affect the letters in the word wallet. And the colors on the spinner don't affect the letters in the word wallet. They're all completely independent of each other. Okay, so what we're going to do in the first example, number 4, we want the probability of getting 5 on the die and the letter L in wallet. So again, we're going to treat these as simple probabilities first, and then we can multiply them to get the compound probability. So let's start by getting 5 on the die. Okay, well, we know a die has 6 sides, so my denominator is going to be 6. And there's only one 5, so the probability of getting 5 is 1 out of 6. And then for L in the word wallet, well, looking at wallet, I see 2 L's out of 6 letters. And I'm going to multiply these in order to get my answer. Okay, so when I multiply those, 1 6 times 2 6, that's going to give me 2/36. And I can simplify that down to 1 1/18. Okay, so my final compound probability here is going to be 1/18. Okay, I want to show you one other thing too. Remember when you multiply fractions that you can simplify early if the numerator and denominator have common factors. Okay, so like this 2 and this 6, or this 2 and this 6, you can simplify by a factor of 2. 2 goes into 2 once, 2 goes into 6 3 times. Now it's 1 times 1, which is 1, 6 times 3, which is 18, and that gets me to my simplified answer right away. Okay, in question number 5, we want to get an even number on the die followed by the color yellow on the spinner. So even numbers on the die, that's 2, 4, and 6, so 3 out of the 6 sides. Yellow on the spinner, well the spinner is labeled green, red, and yellow, so that's going to be 1 out of 3. And I'm going to multiply them to get my compound probability. 3/6 times 1/3 is going to be equal to 3/18, and that's going to simplify down to 1/6. Again, I could simplify these 3's early if I wanted to. Those would both become 1's, and then again, there's going to be my 1/6 for my compound probability. In example number 6, we want the probability, we're going to be using all 3 items now. We want to get a 3 on the die, green on the spinner, and a vowel in the word wallet. Well, to get a 3 on the die, that's a 1 out of 6 chance because there's 1 3. All right, getting green on the spinner, that's a 1 out of 3 chance. Only one of the 3 sections is labeled green. And a vowel in the word wallet. Okay, well, A and E are the 2 vowels, so that's going to be 2 out of 6. And I'm going to multiply all of these together. So with my numerator, 1 times 1 times 2 is 2. With my denominator, 6 times 3 is 18. 18 times 6 is 108. And that would simplify down to 1 out of 54. And again, you could simplify early if you wanted to. 2 and 6 have a common factor. 2 goes into 2 once, into 6 3 times. So 1 times 1 times 1 is 1. 6 times, well, I'll do this a different way. 3 times 3 is 9. 9 times 6 is 54. So I have a 1 out of 54 probability for this compound event. Number 7. I want the probability of getting a number less than 5 on the die, red on the spinner, and a consonant in the word wallet. Okay, to get a number less than 5 on the die, that's the numbers 1, 2, 3, and 4. So 4 out of the 6 on the die. Red on the spinner, that's 1 out of the 3 sections. That's the 1/3 probability. And consonant in wallet. Remember that a consonant is any letter that's not a vowel, so that's going to be W, L, L, and T. So that's going to be 4 out of 6. And again, we're going to multiply these together. Okay, so 4 times 1 times 4, that's 16. We said over here that 6 times 3 times 6 was 108. And this will simplify down to, both of these numbers are divisible by 4, 4/27. Okay, simplifying early, both of these 4/6 I can simplify down to 2/3. And that'll be a 2/3. So again, 2 times 1 times 2 is 4. 3 times 3 is 9. 9 times 3 is 27. So there's our compound probability. Okay, and our last example, it said if you rolled the die twice, what's the probability that you would get a 3 2 times in a row? Okay, so we want the probability of 3 followed by 3 on the die. Okay, well, to get the probability of 3 the first time, well, there's only 1 3 out of the 6 sections, so that's a 1 out of 6 probability. Times, all right, to get 3 again on the die, well, again, that's just going to be a 1 out of 6 probability. A 6 times a 6, that's going to give us a compound probability of 1/36. Okay, so again, if you've got compound events, that's going to be more than one event. Break them up into simple probabilities first, and then you can multiply to get the compound probability. And then again, independent probability means that the second probability is not influenced by the first.